Good day. So this is a lecture related to imaging equipment and maintenance, related to electricity and a basic introduction to the X-ray tube. Okay, so first we need to define what is electrostatics. So electrostatics can be basically defined as the study of stationary charges. Okay, so electric charges comes in discrete units that are either positive or negative. So that those are the important charges at okay, so we have when it comes to our course, when it comes to the rad techno course, but we are previously we dealt with the atomic structure, in which the atoms consist of, you have the centrally located nucleus, and then you also have the orbiting electrons. Okay, so in that nucleus you have your protons and then your neutrons. So the charges that are responsible for the charge also of the atom are the electrons and then the protons. Okay, so the neutrons are neutral, they are neutral in charge. So electrons are negative, protons are positive. The electrons and protons are the smallest units of the electric charge. The electron has 1 unit of negative charge. The proton has 1 unit of positive charge. And thus, electric charges associated with an electron and a proton have the same magnitude but opposite signs. Again, electron is negative, and then the proton has a positive charge. Okay, so in dealing with electricity, now we also have electrification. So how can we be electrified? How are objects electrified? So it can be either of these 3 things. Generally, we have 3 ways in which objects can be electrified. So electrification can be created by either contact, friction, or induction. Okay, so friction, like for example, you in this image, taken from the book of Bushong, you have a person here who is combing his hair, and then the comb, once it is brought close to strips of paper, well, it will the strips of paper will be attracted towards the comb. That is a simple experiment we do as a kids. We try to comb our hair, we try to brisk the comb, we try to comb our hairs briskly, and then try to attract the strips of papers that are on the table or on the desk. Okay, so that is friction. When you try to comb your hair, that creates friction, and because of that friction, some of the electrons may be transferred towards a comb, or maybe some of the electrons will be transferred towards your hair. And that when you try to put the comb closer to a piece of paper or the strips of paper, then there is contact. Okay, so when you try to place 2 objects closer together, you try to have them in contact, then that's the time that some of the electrons may be transferred from one object to the other, therefore creating attraction. By the basic laws of electrostatics, not one of them is unlike charges will attract, and then like charges will repel. Okay, and then induction is simply creating charges or inducing electrification without the objects touching each other. Okay, so like for example in this image now, so the 2 objects is not touching each other, but then the object and the sphere has been electrified because of the positively charged glass rod. So later on we'll try to understand now. Okay, so according to the laws of electrostatics, number 1, you have unlike charges will attract, like charges will repel. And then in Coulomb's law, this number 2, electrostatic force is directly proportional to the product of electrostatic charges and inversely proportional to the square of the distance between them. Number 3, electric charge distribution is uniform throughout or on the surface. And then last, electric charge of a conductor is concentrated along the sharpest curvature of the surface. Okay, so first we have unlike charges will attract, and then like charges will repel. So you have images, you have an illustration here. First, you have a proton, that is a positive charge, being represented as the force of a positive charge is going outward. And then letter B, a negative charge, the force of the negative charge is going inwards. And then you have letter C, letter D. Letter C is both positive, letter D is both negative, letter E, positive and negative, and then letter F, this is a neutron. That means neutral ang charge. Okay, so again, unlike charges attract, like charges will repel. So if you have two positive, then we follow this rule. Like charges will repel. If you have two negative, again, like charges will repel. If you have a positive and then a negative, then unlike charges will attract. So that means a positive will attract negative, and a negative will attract positive. So let's try to go back to the image. Okay. So if you have a positively charged glass rod, what will happen to a neutral object? Can you show this is a neutral object supposedly? But then once the positively charged glass rod came close but not placed in contact, came close to the object, to the sphere, then what happens is the positive, since the glass rod is positively charged, the positive charges of the sphere has been repelled. They have been repelled, and then the negative charges has been attracted. So that means it has been electrified. So if an object, like for example, if I would try to touch this sphere, then some of the electrons on my hand will be transferred towards the sphere. Okay, so that means I will be electrified. Okay, so similar also, when it comes to friction and contact. When you try to walk inside the mall, like for example, it's very cold, tugnaw kayo inside of the mall, and then when you're walking, you are placing your shoes directly in contact with the floor. Tapos imong ipa-slide ang imong shoes, and then if you will come in contact with one of your colleagues, you will be electrified. No, nice part mahitabo. So that is actually part of electrification. Okay, so second, you have the electrostatic Coulomb's law. The electrostatic force is very strong when objects are close, but decreases rapidly as objects separate. This inverse square relationship for electrostatic force is the same as that for X-ray intensity. Okay, so basically when two objects are far, like similar to a magnet, when two magnets are close to each other, their force attraction is very high. Okay, so but when the two magnets are far from each other, they do not try to attract each other. Okay, so similar also to a magnet, like charges and unlike charges, like poles and then unlike poles. But when you try to place both north poles together, they will try to repel each other because they are like poles. And then when you try to attract the south pole towards the north pole, then there is a attraction. There is an attraction because they are unlike na mga poles. Okay, so similar na sila mga og mga rational. Okay, so basically Coulomb's law nga lang ihang giingon nga when two objects are close to each other, then the force of attraction increases, and when you increase your distance between the two objects, then the force between them, the force of attraction between them, greatly decreases. Okay, third, you have electric charge distribution. Electric charge distribution is uniform throughout or on the surface. Like for example, you have a cord of wire, cross-section of an electrified copper wire showing the surface of the wire has excessive electrostatic charges. Okay, so like for example, you have a charger, and then if you have a charger that is plugged to the electricity, and then parts of your charger has been exposed. So for example, gikit-kit sa ilaga, or maybe because too much use na sige kapilo ang imong charger, and then some parts of the charger has been exposed, the copper wires has been exposed. Okay, so when you try to hold that part, now possibility is some of the electrons will be transferred towards your finger, towards your hand, o sa nga part ang imong na place in contact with that exposed copper wire. Okay, so some of the electrons gikan dere sa imong electricity will be transferred towards your hand, from the copper wire towards your hand. Okay, so diba, any part of your charger, any part of the, for example, extension wires in which the copper wires has been exposed, is always a danger. Always a danger, because the electrons will be passed towards your body, which will of course electrify the person. The last electric charge of a conductor is concentrated along the sharpest curvature of the surface. So for example, you have a cathode rod, similar also to a taser. Similar to a taser. Electrostatic charges are concentrated on surfaces of the sharpest curvature. The cathode rod is a device that takes advantage of this electrostatic law, and also similar na sa taser. When you have a taser, you have a cathode rod. The electrons are concentrated on the sharpest curvature, because when this cathode rod, for example, the prongs of the cathode rod will come in contact with the cow, then these electrons will be transferred towards the cow, which will electrify the cow. No, too much electron ang ma-receive ni cow. Okay, so similar also to a taser, the electrons will be transferred towards the person's body, which will electrify the person. Okay, so next we have electric potential. Electric charges have potential energy. Electric potential is sometimes called voltage, especially sa when we are dealing with that physics. We try to define and also call electric potential as voltage. The higher the voltage, the greater is the potential to do work. Diba? That is one of the basic forms of energy, potential energy, the ability to do work by virtue of position. You have your electric charges, even if they are stationary. We are dealing with electrostatics. Even if they are stationary, they are still able to do work, even without moving. Okay, so X-ray imaging systems usually require 220 volts or higher. The volt is potential energy per unit charge, or joule per coulomb. Okay, so for example, here in the Philippines, diba, we have from our electric companies, the supplied electricity is already 220 volts. Okay, like for example, in the US and some other countries, they have only 110 volts coming in from their electric companies, so that should be adjusted to 220 volts in order for the X-ray imaging system to work. Next is electrodynamics. So when you compare electrostatics and electrodynamics, electrostatics is the study of stationary charges. Electrodynamics is the study of moving charges. So basically the terminology is static and then dynamic. So static, that means stationary, and then dynamic, that means there is movement. Okay, so we recognize electrodynamic phenomena as electricity. If an electric potential is applied to objects such as copper wire, then electrons move along the wire. This is called an electric current or electricity. Okay, so basically the potential energy, the electric potential, allows electrons to move. Okay, so very important when it comes to X-ray production also, and also inside of the X-ray tube. Electric potential allows electrons to move. Okay, so always remember that. Okay, so when it comes to electricity, we also have different electric states of matter. You have an insulator, a semiconductor, a conductor, and then a superconductor. So an insulator does not permit electron to flow. This is the basic definition of an insulator. Is it does not allow electrons to flow. Okay, so like for example, when you have a charger, you have extension wires. Basically all of the appliances to the copper wires are covered with plastic. They are covered with rubber. That is because uh, rubber does not permit electrons to flow within them. So that means the electrons are traveling across the copper wire, but then they cannot cross the rubber surface. So that's why when you try to hold your charger, you try to hold extension wires, even if they are already plugged in the main electricity supply, we are not electrified. Unless of course, parts of the copper wire has been exposed. Okay, so that's why when parts of the copper wire has been exposed, like for example in your charger, in your extension wire, you try to cover that with an electric tape, which is also rubber based. Okay, and then also you have glass, extremely high resistance, and then necessary with high voltage. So that's basically the characteristics now. But then basically an insulator can be defined as a material that does not allow electrons to flow. So that means if you do not want electrons to flow, in order for an object not to be electrified, then you use an insulator. Next, you have a semiconductor. A semiconductor can be conductive and resistive. Now, semiconductors can, in some cases, they can be a conductive material, and then they can also be an insulator. Now, when you compare an insulator versus a conductor, insulator does not permit electron to flow. A conductor allows electrons to flow. Now, it allows electrons to flow, and then the semiconductor is in between them. You have it can be a conductive material. It can also be an insulating material. Okay, so it could be constructed as a material that can be turned on and off on the basis of electricity. Okay, and then you also have a superconductor. Superconductor, this is a material that has no resistance to electron flow. Compare that to a conductor. Conductor, napa na siya slight nga resistance, napa siya resistance. Then when you compare that to a superconductor, superconductors, there is no resistance to electron flow, but they require, they require a very cold nga temperature. Okay, so if they are below the freezing point, so that means that there is no resistance to electron flow already. Okay, so you also have the symbols and functions of electric circuit elements. This is a symbol for a resistor, a symbol for battery, a symbol for a capacitor. Capacitor momentarily stores electric charges. Transformer, which will be discussed later, increases or decreases voltage by fixed amount, and then will only operate through AC only. And then you have a diode. A diode allowed electrons to flow in only one direction. Okay, so since you're dealing with electricity, we also have different electric circuits. So electric current is measured in ampere. Okay, so take note of that. So nalata ganina you have your voltage. Now when it comes to technique, you have our primary mga technique factors. You have KVP and then MAS. Okay, so KVP nana dito si V, si voltage, and then MAS nana dito si A, so nana si electric current. Okay, so electric potential is measured in volts. Again, electric current is in ampere. So depende na dayo sa need sa ato ang X-ray tube. Like for example, diba, when you try to adjust your technique factors, we usually refer to the electric potential as kilovoltage rather than voltage, because we need a lot of volts, we need a lot of electric potential. And then you also have your you also have your electricity, which is measured in MA. No, MA. The S is simply for the exposure time, the seconds. Then you have MA. That means from A, we lessen the unit to a milli, no, milliamperes. Okay, so we need a lot of volts, but then lesser amount of electricity. Okay, so electric resistance is measured in ohms, which is important now in dealing with electricity. So electrons at high voltage have high potential energy and high capacity to do work. So if electrons flow is inhibited, then the circuit resistance is high. Okay, so inhibited, that means the electrons are not allowed to flow. So that means the resistance is very high. So that means if you have an insulator, that means those are the materials that does not allow electrons to flow. So that means they have very high resistance in them. Okay. So in Ohm's law, the voltage across a total circuit or any portion of the circuit is equal to the current times resistance. So basically represented as this. No? The voltage is equal to the voltage across the total circuit or any portion of the circuit is equal to current. This is I. Naka na siya, intensity of the current, letter I. And then resistance na siya, R. Okay, so I is measured in amperes. And then R is measured in ohms. Again, balik ta. Na siya. I or the electric current measured in amperes, and then electric potential measured in volts, diba, VIR, and then electric resistance measured in ohms. Let's try to write that one here. V equals IR. Okay, so I is measured in, then R is measured in. If you have, that means volts equals how much is the value of your A, and then how much is the value of your R. Okay, then that would result to your voltage. And then if ever the question would relate to how much resistance is present across the electric circuit along the electric path, then they can use this solution or formula. You also have, if the question is related to how much current is needed or how much current is necessary in order for all of these factors to be followed, then you use this formula. Okay, so you also have in relation to different electric circuits, you have series and then parallel na mga circuits. So very familiar na mga terms when it comes to electricity. You have series circuit and also parallel na mga circuits. Okay, so main difference between series and parallel circuits. So you have the illustrations here. This is a series na circuit, and this is a parallel na circuit. In a series circuit, all circuit elements are connected in a line along the same conductor. So again, you have here all the elements are connected along the same conductor, or basically you have only one wire according to the illustration you have here. So that's why when you try to represent it, again, katong sa mga Christmas lights. Now, if one of the Christmas lights will malfunction, now if one of these diodes will malfunction, then that means the rest of the parts of the circuit element will also not function because of one malfunctioning conductor, because of one malfunctioning na Christmas light. Okay, so you have the rules for series circuit. The total resistance is equal to the sum of the individual resistances. You have here, you have RT, that is the total resistance. R1, how much is the resistance for this, and then how much is the resistance of this, how much is the resistance of this. Okay, so you have RT, again, total. Okay, so like for example, we'll try to place values here. This is, let's try to say 2 ohms. This is 4 ohms. 4 ohms. Then this is 6 ohms. That's basically 2 ohms na siya, plus 4, then plus 6. So the total resistance is equal to 12, measured in ohms. And then you have IT, that is the, let's say IT, that is the total intensity. So I1, for example, you have I1, sorry. So the intensity, again, this is measured in amperes. So the current through each circuit element is the same and is equal to the total circuit current. So like for example, you have IT niya, ang total niya is 5 amperes. Siya, 5A. So that means I1 is equal to 5A. I2 is equal to 5A. So like for example, this is 5A. Ano mga I here? 5A. Then 5A. Then also 5A. Ayun. Okay, so that means all, no? That's why it is represented as equals, no? Equal sign. Check. Okay, so you have same in lahang mga values. And then for you to compute the V, you simply have to use the Ohm's law. V-I-R. For example, V1 is equal to I, that is 5 multiplied by R1. And then next diyon, you have for V number 2, voltage number 2, that is simply 5A multiplied by this 4. Then you also have for V number 3, voltage 3, that's simply V3 equals IR2 IR3. Okay, so the sum of the voltages across each circuit element is equal to the total circuit voltage. So, wala mo yung buhaton. Okay, so next we have the parallel rules for parallel circuit. The parallel circuit contains elements that are connected at their ends rather than lying in a line along the same conductor. Okay, so rules for parallel circuit: the sum of the currents through each circuit element is equal to the total circuit element. So basically I1 plus I2 plus I3. Then voltage across each circuit element is the same and equal to the total circuit voltage. And then the total resistance is inverse of the sum of the reciprocals of each individual resistance. Okay, so later na to i-compute si I. Let's try to leave the I as blank. Okay, na. And then you have, like, for example, the voltage na to. Try to use the same number. You have 5, that is 5 volts. Oops, sorry. IT equals question mark. Volts is equal to, because again, IT is question mark. Volts equals 5 volts. Then you have R. You have 1 over RT is equal to 1 try to say this is 10 plus 1 over 20, then plus 1 over 30. We simply have to compute for this. So 1 over RT is equal to 1 over 10. How much is that? 1 over 10 is equal to 0.1 plus 1 over 20. 1 over 20 is 0.05. Then plus 0.033. So, and then total, you have 0.1 plus 0.05 plus 0.033. Okay, so that is 1 over RT is equal to 0.183. So this is not our final answer. No? Kinaka-reciprocal pa man atong original, atong total resistance. So you simply have to transfer this. Transfer, and then also reciprocal of this. So that would result to RT is equal to 1 over 0.183. So equal na yan. RT is equal to, 1 divided by 0.183 equal to 5 point, let's try to put only 2. 5.46. Okay. So you have the volts here, 5 volts. You also have the resistance is 5.46 ohms. So try to compute for the IT. So I1, the formula for that is I is equal to V over R. So I should be equal to V. Pila ang V? That is 5. So 5 divided by first is gamay kaya itong voltage. Let's try to use Let's try to use 100 volts. 100 volts ang ating butang dia. Okay, 100 volts. So 100 volts divided by, for example, 10. For the first resistance you have here, you have to use these numbers here. Do not use this one. Use the original values nila kani. Mga ohms ni sila. So that is divided by 10, divided by 20, divided by 30. So 100 divided by 10, that is still 10. So I1 equals 10 plus divided by 100 divided by 20, that's 5, and then plus 100 divided by 30 is 3.33. 3333. Okay, so that is 10 plus 5, 15, so 18.33. 18.33. Klaro pa ba? Ayan. Okay, so this is your total current. Okay, so that is measured in A. A. Okay. So next we have related topics also. We have direct current and then alternating current. And someone trigger na. You have alternating current and then direct current. So direct current, that's basically DC. Shortcut niya DC and then AC. Direct current and then alternating current. So the direct and then alternating would actually refer to the movement of the electrons. No, malagin na siya ang iyang pasabot gina. Either they are direct or alternating sa ilang direction. So when you say direct ang current, no, you have a direct current, so that means the electrons will only flow in one direction. No? Electrons flow in one direction only. Excuse me. So that is for the direct current. When you have an alternating current, again alternating, so movement again of the electron. Okay, so electrons flow alternately in one direction and then the other. So basically backwards, forwards, backwards, forwards, backwards, forwards. That is for the alternating current. That is the movement of the electrons. When you have a direct current, the electrons will only move forward, or maybe the electrons will only move backward. That is the direct current. Okay, so it's important that when it comes to our X-ray tube. Okay, inside of our X-ray tube, we only operate through direct current. Okay, so even if the electricity coming in from the main power supply is AC, alternating current, but then the current and then also the voltage is being converted para mahimo siyang direct current, and that is through rectification. Okay, so again, direct current, electrons flow through only one direction, no? Flow in one direction only. And then if you have alternating current, that means the electrons are moving forward and then backward, then forward, backward, forward, backward. So they say they are alternating in the direction of movement. Okay, so alternating current is represented graphically as a sinusoidal electric waveform. So and this is the positive cycle, kani siya positive. Then this is the negative cycle, nasa ubos, negative cycle. So that is an alternating current nga waveform, sinusoidal. Okay, so silingan po dayon nga topic. You have electricity and magnetism. Then later on, when it comes to the trigger, there is a relationship, Faraday and then kang Oersted. There is a relationship between electricity and magnetism. Electricity creates magnetism, and then the opposite dayon, magnetism creates electricity. Okay, so magnetism, diba? Magnetism, that's basically one of the forces naturally occurring forces there sa Earth. So there are three principal types of magnets. You have the naturally occurring magnets, so for example our Earth. But the Earth is the best example for a naturally occurring magnet. Since it is rotating, it's moving, it has its natural magnetic field, which shields us from the rays of the sun. Some of the particles from the sun is interacting with the magnetic field of our Earth, and then once the magnetic field of the Earth will be bombarded, and then it will there is a disruption in the magnetic fields nato. So some of the light, the Earth tends to, or the magnetic field tends to form a light across its main source, dito lapit sa North Pole and then the South Pole, commonly known as the Aurora Borealis. Okay, so that is actually one of the interruptions sa ato ang magnetic field, the lights being created. Okay, and then artificially induced permanent magnets, like for example, very common kitong mga horseshoe bitaw og shape, itong letter U og shape ng mga magnets. Bantay mo ana ang yan nagporma. You have letter N na rin nakabutang, and then this side is S. Now you have the North Pole and then the South Pole. They can be magnetized. Okay, and then last is the electromagnets. Also can be artificially induced, but then they are electromagnets, a different type of magnets. Okay, any charged particle in motion creates a magnetic field, which was also represented and then conducted by Oersted. Diba, when Oersted tried to experiment, nabada ang illustration. Oersted tried to experiment. He has a compass here in which it is directed. It is normally directed or magnetized towards the North Pole of the Earth. But then, since when he experimented, he tried to put that compass near near a wire that has current passing through it. So once the electric path has been turned on, then the compass turned its arrow towards, not towards this portion. So that means this area is this area has a magnetic field. Now it creates a magnetic field, so that's why he concluded that there is a magnetic field. Now when electricity or when electric charges are traveling, they create magnetic fields. They produce magnetic fields. For example, you have an electron traveling, and then as the electron travels, magnetic field is being produced. Okay, so this is a basic type, a very simple way of introducing and then also experimenting with electromagnets. You have a battery, a copper wire, and then a nail. So when you try to put the nail, or when you try to place the copper wires in contact with the poles of the battery, sa ihang bottom and then sa top niyang part, so electrons will be allowed to flow across this wire, across this copper wire, which will allow the nail, which is a ferromagnetic material, to become a temporary magnet. Okay, so that means it becomes an electromagnet. So the nail is not a magnet itself, but rather it becomes a temporary magnet because of the electricity passing through it. So that is the basics of the electromagnets. If electrons are passing through the wire and then there's a nail here, so that means it can attract small pieces of metal. Okay, so earlier we had the electric states of matter. This time we have magnetic states of matter. So you have a non-magnetic material, you have a diamagnetic material, you have a paramagnetic material, and then a ferromagnetic material. Non-magnetic, they are unaffected by a magnetic field. Like for example, this one, unaffected by the magnetic field. So that means, for example, you have a magnet. Well, when you have a magnet, there are objects that cannot be magnetized. Okay, so that means they are non-magnetic. No, they cannot be attracted. They are unaffected by the magnetic field of the magnet. And then, if you have a diamagnetic material, a diamagnetic material is weakly repelled from both poles of the magnetic field. Dili siya strongly repelled. No, weakly repelled lang siya. Na say weak nga repulsion. Dili siya ma-attract yun ayo. And then, a paramagnetic material, for example, gadolinium, weakly attracted to both poles of the magnetic field. So, the property of gadolinium being a paramagnetic, so it is important in MRI, no, because gadolinium is the contrast material being used for an MRI examination, for contrast examination for MRI studies. And then, ferromagnetic material can be strongly magnetized. Okay, so these are the ferromagnetic materials. These are the objects that can be turned into an electromagnet. Ferromagnetic materials or objects can be made into magnets by induction. Okay, they can also be turned into the electromagnet. The electromagnet. So if you have a ferromagnetic material, for example, here you have an iron. So iron attracts, no? It attracts the magnetic field lines. So when objects attracts the magnetic field lines, then that means they can be strongly magnetized. Now, if they do not allow, or if they are not attracted, or if objects will not be affected by the magnetic field lines, then they cannot be attracted towards the magnet. Okay. So again, ferromagnetic material, you have iron here, it attracts the magnetic field lines. And then you have a copper, non-magnetic material, it is unaffected. It does not affect the magnetic field lines of the magnet. Okay, so the magnetic field is represented by imaginary lines that form concentric circles centered to the wire. For example, kanina sa electron. You have the electron, and then you also have the magnetic field being represented as circular nga form. No? Ayan na siya. Concentric nga mga circles centered on the wire, no? Centered on the path of the electric current, centered in the path of the electrons. Because as electrons flow through this wire, no, they create magnetic field lines. And then the magnetic field lines is being represented as this, kini mga concentric nga circles. Okay, so if it is strong enough, then of course it can attract, no, it can attract magnetic pud sa nga mga objects. Okay, like for example, the compass has a north pole and then a south pole, no, when you try to look at the compass. Then na siya arrow, and then na siya north nga symbol, and then na siya south nga symbol. And then the arrowhead niya tends to find out where the north, no, the natural north not of the earth. You have the north pole. Okay, so that means this part here is actually a south pole of a magnet. The south pole is a magnet because it is attracted to the north pole of the earth. And then this is the north pole of the arrow. Na dari dapit mo ang north pole sa arrow because it is attracted to the south pole of the earth. Okay, so stacking more loops on top of each other increases the intensity of the magnetic field running through the center or axis of the stack of loops. Kapag sa kanisya, this is only a straight na wire. If straight ang wire, so that means the intensity of the magnetic field lines is scattered throughout. No? So when you try to create a loop of wire, for example this one, a loop of wire is simply called a solenoid. Okay, so solenoid ni siya kaning coil, no, coil of wire, or loop of wire. So stacking more loops on top of each other increases the intensity of the magnetic field running through the center or axis of the stack of loops. So, if ever we will use a solenoid, kaning naka-coil na wire, the magnetic field lines nila, the magnetic field is increased compared to a straight lang siya nga wire. No? Mas better ni siya if ever atong i-coil ang ato ang wirings. Okay. So next we have electromagnetic induction. So we will try to relate these topics. Electromagnetic induction. Electromagnetic induction is an electric current is induced in a circuit in some part of the circuit in a changing magnetic field. Now, being introduced to us by Faraday's experiment. Kani siya. Magnetic field, kato ganina si Ørsted. According to Ørsted, electricity creates magnetism. A moving electric particle, like for example an electron, creates magnetic field, creates magnetism. So electricity creates magnetism. And then also, so the relationship between electricity and magnetism has already been proved. And then later on, Faraday also proved that magnetism can also create electricity. So basically, vice versa. Electricity creates magnetism, then magnetism creates electricity. Okay, so according to Faraday, nagyapoy rules on how the electricity or an electric current can be induced in a circuit using a magnetic field. Okay, so the magnitude of induced current depends on four factors: the strength of the magnetic field, the velocity of the magnetic field as it moves past the conductor, and then the angle of the conductor to the magnetic field, and the number of turns in the conductor. So number of turns is related to the solenoid. The solenoid again is a coil of wire. It's a coil of wire. It's basically a solenoid. Okay, so kanisha velocity of the magnetic field, so that's why na-arrow there, no? Because electricity, if ever you have a magnet, no, you need to move the magnet in order to create or to induce electricity. Without a moving magnet, without a moving magnetic field, then there is also no movement on the part of the electrons. Okay, so to kanina, moving electron creates magnetic field. And then this time, a moving magnetic field allows the electrons to move. Okay, muna according to Faraday. Okay, so when it comes to electric induction or electromagnetic induction, it is important sa ito because we are actually using this type of technology in our X-ray tube. So the type of motor used in X-ray tubes is an induction motor through electromagnetic induction. So in our X-ray tube, we have a rotor. The rotor is a rotating part of our X-ray tube. Mo-rotate na siya. But then there is no electricity being provided towards the rotor. The rotor is allowed to rotate. It is allowed to turn itself because of the stator. Okay, so no electric current is passed to the rotor. Nakataong na-mention na there is no electric current being passed to the rotor. Instead, current is produced in the rotor windings by induction. Okay, so natay stator dre. So electricity is being passed through here. Yan siya. Electricity is being passed through the stator. And then as the stator is being energized, magnetic fields is being created. There is a magnetic field being created by the stators, and then as the stators is being energized, magnetic field is being produced. Then it also allows the rotor, or the rotor windings to produce current because of the magnetic field. Electricity creates magnetism or magnetic fields. And then the magnetic fields also creates electricity. Stator, electricity, and then na siya yung mga kaning mga metals dire. These are actually electromagnets. So that means if ever na ay current dire, it will turn that current into a magnetic field, and then that magnetic field in turn will provide the current for this one, for the rotor itself, for the rotor to rotate. Okay, so next we have the transformer. Transformers changes the intensity of alternating voltage and current. So the transformer is a device that uses interacting magnetic field produced by changing electric currents. Okay, so like for example, kanina you have a solenoid. So nakita po sa nato dre, this is a solenoid. Okay, mga solenoid. And then you have an iron core. Iron core, these are ferromagnetic materials. Ferromagnetic. And again, ferromagnetic material can be turned magnetic. Can be turned magnetic through electromagnetic induction. Electromagnetic induction. Shortcut. Induction. Okay, so similar itong sa rotor and stator ganun. Electricity provided to the stator, and then stator provides these ferromagnetic materials, the ability to create magnetism, and then magnetism in this ferromagnetic materials allows the rotor to produce its own current. It allows the electrons to flow. And then because of that electron flow, because current is already in the rotor, so the rotor will turn the diode. It will rotate. Okay. Okay, so in a transformer, this is our transformer. This is a letter A. This is a closed core transformer. Letter B is an autotransformer, and then letter C is a shell type transformer. Okay, so in a transformer, only this is the primary coil. This one here, this is the primary coil, and then this is the secondary coil. So electricity from the main source and the, for example, from the electric companies coming in towards the department, towards the transformer of the X-ray tube. This is the primary side, this is the primary coil. Electricity will only be provided towards this side, towards this coil. Okay, and then the electricity from this in this coil will allow the iron core is a ferromagnetic material, to become a magnet, to become an electromagnet. And because it will become a magnet, according to Faraday, so magnets of magnetic field can create electricity. But again, we need a changing magnetic field. No? Similar also to alternating current. Okay, so that's why the transformer, transformer creates electricity by uses interacting magnetic field produced by changing electric currents. Electric currents would refer to AC. Okay, alternating current. Okay, so why is it important that we use AC in a transformer? So let's try to go back to this. Okay, so like for example, in this illustration, this is a direct current. Electrons are only traveling in one direction. So for example, we'll follow the arrow. So this is the flow of the electrons, and then the magnetic field is going that way. Okay, so this is DC. This is a constituent of a DC. Only one entrance, one exit. Okay, for the electrons. So they only travel in one way. And then the magnetic field is only going upwards. That is a DC. But then in a transformer, we need the magnetic field to be changing. Now we need the magnetic field to be changing, alternating magnetic field. We need the magnetic field to also point downward. Okay, so in order to do that, in order to change the magnetic field of the solenoid, so we need to apply AC instead of DC. Okay, so AC. So because of AC, again, now AC will allow electrons to move back and forth. Now forward, backward. They will try to go forward, backward, forward, backward, forward, backward. So that is the movement of the electrons. Okay, so instead of going just towards the right, they will go back towards the left. They will go back to the original pathway. Sila. Okay, so forward, backward, forward, backward. Okay, so that is the movement of our electrons now because of AC. Okay, so as the electrons are traveling forward, the magnetic field is pointed upward. And then as the electrons are traveling backwards, the magnetic field will point downward. Now because of this changing magnetic field, according to Faraday, changing magnetic field allows electrons to move. And then, of course, movement of electrons is simply defined as electricity. So that's why changing magnetic field creates electricity through the movement of the electric charges or the electrons. Okay, so again, now you have the primary side, the secondary side, the primary coil, secondary coil. AC is provided in this coil, this one. AC is provided in this coil, and then because of the AC, the magnetic field is changing, going that way, and then circle na siya na. So first is paana iyang direction, and then second bali na siya, going towards the other direction. And because of that changing magnetic field, electrons in this coil are allowed to move, thereby creating electricity. Okay, so the voltage change across the transformer is proportional to the turns ratio. So turns ratio basically katong sa solenoid, related to the solenoid, the coil of wire. Solenoid. Again, this is the coil of wire. The number of turns, the number of coils niya, that's basically the number of turns in a transformer in a coil of wire. Okay, so you have here VP over VS over VP, and then NS over NP. V is the voltage, And then N is the number of turns. Number of turns. Kani siya, the turns ratio. Okay. So again, the voltage change across the transformer is proportional. Na that's why proportional po sa ato ang formula. So, na sa taas ang duha ka S, that is the secondary, and then the primary din na sa bus. Again, V is for the voltage and is for the number of turns. A transformer with a turns ratio greater than 1 is a step-up transformer. Okay, because the voltage is increased or stepped up from the primary side to the secondary side. So that's basically the main function ato na sa ato ang mga transformer. We step up the voltage, kaya diba? Like for example, from the Sipalco sa Philippines, we have 220 volts coming in from the electric companies, and that will be converted into, like for example, 70,000 volts. Now 70,000 volts, so that's why we need a step-up transformer. We need a high voltage transformer. So basically, the transformer, the step-up transformer, steps up the voltage. Now it increases the voltage. Okay, so in our X-ray imaging system, we both have a step-up transformer, and then the other one is a step-down transformer. So we both have them. So when the turns ratio is less than 1, the transformer is a step-down transformer. Siya. Okay, so turns ratio, again, related ang nila, we'll try to understand the turns ratio kani siya. This is the primary turns. These are the secondary turns ratio. Secondary. This is secondary coil, primary coil. If the primary coil is, let's just say 70, and on the secondary coil there are 150, so since proportional man ang number of turns and the voltage, if the number of turns is increased from the primary to secondary, then that means the voltage will also increase. So let's try to do an opposite. If the primary coil is 150, the primary turns is 150, and then the secondary turns is only 70, that means the secondary is less than that of the primary, then this is a step-down transformer. This one is a step-up transformer. So now, the more number of turns secondary, then the higher the voltage. If the secondary coils is less than that the number of the primary, then that is a step-down transformer. Okay. So next we have the Autotransformer. So na siya construction rin, no? This is an example of an Autotransformer. It has only one winding. That is the basic description of an Autotransformer. So Autotransformer has a single winding and is designed to supply a precise voltage to the filament circuit and to the high voltage circuit of the X-ray imaging system. So an Autotransformer acts as both a step-up and a step-down transformer. So it can, the Autotransformer, since it has only a single winding, then we can have different taps and different wires connected to the Autotransformer, connected to the single winding, and then we can have the Autotransformer behave as a step-up transformer or as a step-down transformer. So same lang ang ilahang same ang ilahang law, same ang ilahang formula. Okay, so ang S is nasa taas and then ang P is nasa ubos na siya. So Vs over Vp and then Ns over Np. Again, na pag more gani ang number of turns secondary, so dapat more po sa diyahang voltage. Okay, so in relation to I mentioned earlier, no, when it comes to electricity, we have an alternating current being supplied by the electrical company, but then inside of the X-ray tube we need DC. We need direct current. We need the electrons to travel in only one direction. Okay, so rectification is the process of converting AC into DC. Now we rectify the voltages across the X-ray tube. Now voltage rectification is important and is required to ensure that electrons will flow from X-ray tube cathode to the anode only. So inside of our X-ray tube, like for example, this is our X-ray tube. The X-ray tube has two main components, the anode side and then the cathode side. So electrons will be coming in from the cathode, and then inside of the X-ray tube, we need the electrons to travel only from cathode to the anode. Okay, we can't allow the electrons to travel back towards the cathode because it will be detrimental. That will result to the to damage to our X-ray tube. Okay, to the whole of the assembly sa atong X-ray tube, that would render the X-ray tube useless. Okay, so inside of the X-ray tube, it should be DC. So that's why we need voltage rectification. So in voltage rectification, we have half-wave rectification, we have full-wave rectification, and then we also have different phases. Okay, so when it comes to voltage rectification, again, remember this one, AC, what is the how is it being represented graphically? Diba? The AC is being represented as this, sinusoidal. Hana siya. Diba? Not siya halfway. This is the positive cycle, this is the negative cycle. Nasa ubos. Yan siya. So, in the X-ray tube na to, in our X-ray tube, this positive nga mga portions, these are the time that electrons are traveling from anode to cathode. Anode to cathode na siya. No, baliday. From the cathode to anode, sorry. From the cathode to anode. Kaya na. From cathode to anode, the positive cycle. The negative cycle would represent the anode to cathode, which is wrong, no? Dili siya pwede dili siya pwede mahitabo. Okay? So again, this is AC. Ano siya, no? AC. Alternating current. Positive, negative, positive, negative. So that means electrons are going forward, going backward, forward, backward, forward, backward. That is the flow of the electrons. Now, again, we need the electrons to only travel from the cathode side towards the anode side. Okay, that is the only flow of electrons that is acceptable inside of the X-ray tube. So how do you do that? Again, rectify the voltage. So in voltage rectification, we have half-wave rectification. The sine wave is not allowed to swing negatively, no? Dili siya gina-allow, or dili na gina-consider ni siya nga portion. So that means it is converted into a DC. Isara na siya sa taas tanan. Okay, so what happens in half-wave rectification? Now, instead of you have a positive and negative cycle, what happened in the half-wave rectification is we only have the positive cycle, and then there is no negative. Positive, there is no negative. Positive, there is no negative. But then the problem with half-wave rectification, if you would, like for example, if we would use this in an actual nga X-ray tube, these peaks, kaniyang pinakatumoy, these peaks of the sine wave, these are the portions in which X-rays are being produced. Okay, so that means if this would be the point of time in which X-rays are being produced, and that means very less or very little X-rays are being produced at a certain amount of time. Now we need that means you need a lot of power and then voltage in your X-ray machine, and then the number of X-rays being produced is very little. So that's a problem with half-wave rectification. Okay, so for a full-wave rectification, again, itong half-wave ganina, the half-wave, the negative cycle for half-wave rectification, the negative cycle is useless. No, they are useless. And then for a full wave rectification, instead of having the sine wave swing negatively, the cycle will be allowed, or the negative cycle will be allowed to swing positively. So that's why muning nahitabo dire. Instead of swinging negatively, they are all allowed to, they are controlled to swing positively. So that means more time is allowed for X-rays to be produced. That means more X-rays will also be produced, which is better for our X-ray imaging system and then also for the patient to reduce patient dose. Okay, and then we also have a three-phase 6-pulse. Okay, so the 6-pulse would refer to, or the three-phase would refer to the number of sine waves. Like for example, this one is only one sine wave. For example, na colors line. Okay, hana lang. This is the first phase. This is the second phase. And then this is the third phase. So there are three phases. There are three sine waves. And then the pulse would refer to the number of pulses per second. Like for example, the measurement is per second. So 1, 2, 3, 4, 5, 6. So for example, this is 1 second. So that means the three phases should produce 6 pulses, and 6 pulses per second. Okay, and then same gihapon, 3 phases, 3 sine waves, but then there are 12 pulses. So that means in 1 second, there should be 12 pulses. Okay, so of course, the more pulses na you have produce per second, the better. Like for example, in this one, like for example, this is only 12 pulse, then this is already 60 pulse. So that means this is better. No? So the modern mga X-ray tubes na to are actually operated at high frequency. Now, we use high frequency na voltage rectification of voltage rectifiers, in which this one dayon kani mga values dere. This is what we call as the voltage ripple. Voltage ripple. So the lesser is the voltage ripple, the better will be for X-ray production. So kanimo ni siyang voltage ripple niya no gamay na lang kaayo. And then compared to this nga 100% siya. So the higher is the value of the voltage ripple, the lesser X-rays will be produced. And then the amount of work that the X-ray tube requires is so much, na too much. And then the X-ray being produced is too less. Okay, so detrimental siya sa X-ray tube, and at the same time detrimental po siya sa patient because it would actually increase the patient dose. So for high frequency, lesser time is needed in order to produce a certain amount of radiation, a certain amount of X-rays, and then lesser time, of course, would also result to lesser patient dose. Okay, so that is the importance of voltage rectification. Okay, so you have the single phase, isa ka sine wave, 3 phase, that means 2 ka phases, and then 3 phase 6 pulse, that means 3 phases, but then there are 6 pulses per time or per second. For example, per second, 1, 2, 3, 4, 5, 6. So like for example, if this is the same measurement there sa taas, kaya siya is only 1, 2, 3. There are only 3 pulses per second compared to 6 pulses per second. So that means this is better. So now the more pulses per second would be better. Now, the more X-rays that will be produced in a shorter amount of time, then better. Para shorter amount po sa nga time atong expose si patient to X-rays. Okay, so in this illustration, this is a full wave rectified circuit, contains at least 4 diodes. This is the basic illustration of itong voltage rectification inside of the X-ray tube, in which again electrons are only allowed to flow from the cathode, from the cathode towards the anode. Okay, so this is the negative side. This is the positive side. Okay, so again, cathode, anode. This is the cathode. This is the anode. And again, electrons are only allowed to flow that way. Cathode to anode. Okay, so take note of these diodes. Kanisya. The diodes, kanisya, ang ilahang direction of arrow ana is the direction of current, and then the direction of current is opposite to the direction of the electrons, the direction of flow of electrons. So that means if this arrow is pointing towards the left, then that means the electrons are going towards the right. So dito padulong atong mga electrons. So again ha, cathode, anode. So let's try to trace the path. This is the path of electron. Ano siya? Dire. Sulod siya sa cathode. Interact with the target. That is the anode part. And then electrons dayon will be allowed to flow towards this side. Okay. So diba wala ni balik si electrons from anode to cathode. Wala sila ni direct o balik. And then after this part, after maabot si electron dire, so it can also be reused. Dari na po siya moagi nga path. Kani. Ana, sa electron dire siya agi nagikan siya ani nga portion. Ana. And then electrons, cathode, anode. Okay. And then pwede na po siya mabalik again. So, same path lang gihapon. Okay, so, diba, the electrons, the voltage is being rectified so that electrons will only be allowed to travel from the cathode towards the anode. Okay, so that is the main purpose ito, rectify na to siya. And again, if ever the electrons will travel from the anode to the cathode, then that means there's a problem with their X-ray imaging system. And then, of course, that would result to damage, and then that will render your X-ray imaging system useless. So next, we have the types of X-ray machines. So there are actually a lot of types of X-ray machines. No? Like for example, kanatong list there, we have general radiography, you have mobile X-ray machine, you have a portable X-ray machine, you have a fluoroscopic machine, you have an X-ray machine dedicated for mammography, and then also for dental imaging. Okay. For general radiography, like for example in the LMDC, in RN campus, those are for general radiography examinations. So those are for, those can be used for general examinations for the head, for the chest, for the spine, any type of X-ray, general X-ray examination. And then they can also be constructed as fixed, fixed sila, or it can be constructed as a mobile X-ray machine. Okay, so when you say it is fixed, then that means it remains in the room. Like for example, sa RN, sa MDC, those are fixed. Na dili man nato siya pwede madala, bisag asa din nato siya pwede tanggalon. And then it is also wall mounted, and then some of the X-ray machines can actually be ceiling mounted. There are X-ray machines or facilities that the X-ray tube are ceiling mounted. Okay, and then for a mobile X-ray machine, like for example this one, all of them are actually mobile. Mobile ni siya, mobile. Kani siya is fixed ni siya. These are fixed. So that means dili sila pwede dalon na din nato sila pwede ipagawas diha nga X-ray room. Okay, kani sila these types of X-ray machine, these are mobile. That means na ay ligid. Now we can push them around. Like for example this one, it has wheels. Na sila, so that means they can be pushed around because they have wheels. If you have X-ray machine that you can carry, pwede nimo mabit-bit gid siya nga X-ray machine, then that is a portable X-ray machine. Kaya mo na siyang gipanganlan as portable because mabit-bit man siya. Mobile, dili nimo na siya mabit-bit. Pwede nimo siya itulod-tulod. Okay, so for a fluoroscopy, the difference nila ni general radiography and fluoroscopy. Fluoroscopy allows continuous emission of X-ray. General radiography ng mga X-ray tube is constructed, and also their imaging system is constructed for single shots. Isa lang ka exposure isa lang ka X-ray exposure per press of button, while for fluoroscopy, one press of button will allow you to expose the patient continuously for approximately, for example, continuous 1 minute exposure, continuous 3 minutes exposure. So depends on the type of examination. Okay, and then for mammography, this is a type of X-ray machine used for mammography na nasa kanang murag clamp niya, diha ipiton ang breast sa patient. And then the dental, wala nakabutang ang dental there. Okay, so the dental is used mainly by the dentist. In our setting this time, now most of the dental X-ray imaging systems are actually in the dental nga department or in the dentist na mga offices. Na wala siya sa general radiology nakabutang. But there are some facilities that the dental is placed in the general radiography area. Okay, this one is a mobile na fluoroscopy. Also, this one is a mobile fluoroscopy unit. Also, this one siya is a general radiography na mobile X-ray unit. So, and then these are the fixed na mga general radiography X-ray units. Okay, so this is just an introduction to the X-ray tube of the basic parts lang niya. For the extended discussion of the X-ray tube, it will be in the final. Okay, so X-ray tube, you have the positive side, which is the rotor, which contains the rotor, kita na mention ito ganina, and then the target. Okay, so the target is one of the most important parts ato ang anode. Notice that is where the X-rays will be coming from. Muna siya ang target. So that is the area of the anode. That is the area of the anode in which X-rays will be produced. So diha gikan atong X-rays diri sa atong target. Okay, so later on we need to discuss what part of the target gyud siya naggikan. And then you also have the cathode, that is the negative side of the X-ray tube. So we have here the negative side, kani siya. This is the cathode, and then this is the anode side. Okay, so the cathode side, two main parts. You have the filament and then the focusing cup. So the filament is where electrons will be coming from. And then these electrons will interact with the target to produce X-rays. Then you also have the focusing cup. The focusing cup helps the electrons to travel in a straight path. Okay, that is the main purpose to focus the path of electrons. Okay, so this is the basic construction of a cathode. The filament, kani siya, kabantay mo ni mga coil of wire, mga solenoid. You have coils of wire there. That's actually the filament. This is the small filament, kani gamay there, no? Gamay dako. Small filament. The small filament. And then this is the large filament. Small na siya, small kay gamay. And then this is the large, dayon, large filament. And then kaning metal dayon dire that surrounds the filament is the focusing cup. So that is the focusing cup of the cathode side. So again, kaning filament, the small and the large filament can be used interchangeably depending on the examination. So like for example, if the examination needs a small amount of X-rays, so lesser amount of X-rays, so we can use the small filament. If we need a lot of X-rays during the examination, like for example, we need to image obese patients, we need to image the abdomen of the patient, so we need to use the large. Okay, you need a lot of X-rays manana. Okay, so again, ako na mention ganina, the filament is where the electrons will come from. So the small filament, then smaller amounts of electrons, then smaller amount of X-rays. Large filament, more number of more number of electrons, then that would also result to more number of X-rays that can be produced. So next, you have the focusing cup. The focusing cup, again, it focuses the path of electrons. It's negatively charged. No? Negative kuno yung charge ani kanya yung focusing cup. So that it electrostatically confines the electron beam into the small area of the anode, no, towards the target. Okay. So without the focusing cup, the path of electrons cannot be focused. So they will interact with any parts of the X-ray tube, no, not just the target, but also other parts of the X-ray tube, which would, of course, it would result to lesser amounts of X-rays being produced because there is only a little amount of electrons that will interact with the target. That means lesser X-rays will be produced. So with the help of a focusing cup, we can focus the path of electrons towards a small amount, towards a small area of the target, therefore focusing the X-ray production in that small area. No? And then the electrons, all of the electrons can be used for X-ray production instead of wasting some of the electrons. Okay, so that's why it is mentioned here, no? Without a focusing cup, the electron beam spread beyond the anode because of mutual electrostatic repulsion. So take note, diba? Electrons, they are all negative. So when they travel, they tend to repel each other. So that's why nagkatag sila. They try to spread across the area. Okay. Also, the focusing cup is negatively charged para ihapod sang ma-focus electrons, no? Ihapod sang i-repel sa electron towards the central point. Okay. And then on the other side of the X-ray tube, we have the anode. The anode is the positive side of the X-ray tube. It conducts electricity, or it conducts electron, or it receives the electrons and then conducts the electrons towards the main electric path, and then it radiates heat and contains the target. So it radiates heat because in X-ray production, 99% of the kinetic energy of the electrons, okay, because electrons are traveling man from the cathode towards the anode. So 99% of the kinetic energy of the electrons will be converted into heat, and only 1% of the kinetic energy of electrons will be converted into X-rays. So just imagine na nga nakadako atong heat production. So the anode should be able to withstand the tremendous amount of heat that it will be receiving from the electron. So just imagine the potential energy, again, katong potential energy. No? Potential energy allows the electrons to travel, from cathode to anode. So just imagine if we provide the electrons with 70,000 volts of potential energy. So that means a tremendous amount of kinetic energy is being carried by an electron, and then of course as it interacts with the target, yang banggaon si target, there are a lot of heat that will be produced. Then of course the one of the most important nga function is it contains the target, and again the target is where X-rays will be produced. Okay, so function conducts electrons from cathode, mechanical support for the target, and then also a thermal dissipator. Okay, so the target, the area of the anode. The target, the area of the anode that is struck by electrons from the cathode. And when electrons struck the target or interact with the target, then X-rays will be produced. Okay, so we have two types of anode, basic mga construction of an anode.
You have a stationary anode and then a rotating anode. Stationary, that means dili may tuyok si target. And then the rotating, basically, iyang iparotate si target. No, kani siya. Kani man iyang important part. Kaya remember, 99% of heat ang maproduce when we allow electrons to interact with the target. So that's why they try to rotate. No? Ilang gid na pa-rotate ang target para ang heat is not focused on only one part of the target. Okay, so the stationary, kani siya, stationary nga mga target can be used for X-ray imaging system that uses low techniques, low technique factors. So for example, low kV, low MA, so pwede na siya stationary nga ano, na for example sa dental siya. And then for rotating nga mga anode, usually used for example sa general radiography, and then also sa CT scan. It also uses an X-ray tube and then rotating anode tube because tremendous amounts of heat is being produced, and it needs to dissipate that heat faster. So that's why the target is being rotated. Okay, so that's the end of the lecture. Thank you for listening.